Okay, welcome. Today we're talking about triangle inequality theorem. We've ran an experiment, or you can run an experiment in which you use a strip of paper, let's say 10 inches in length, and you take the other 10-inch strip, cut it in half to 5 inches. Now the idea is if you were to try to connect those strips at their dots as such, and you continue to slide them in this way, they would never in fact be able to touch in a way in which they would be able to form a triangle, because the two sides are in fact equal to the third side. So the idea is that two sides of a triangle, and I like to use, cannot equal the third. In fact, they need to be greater. So in order to fix this 5, 5, and 5 triangle, which in fact would not be a triangle, you could use sides 5, 6, and 10, because the 5 plus 6 would be greater than 11. Now that kind of shifts us into looking at a few examples of triangles that are and are not triangles, and how to test it, and how you would go about doing that. So let's just look at a triangle that is 4, 8, and 3. So you have 4 plus 8, which is greater than 3, that's okay. You have 3 plus 8, which is greater than 4, that's okay. But the problem lies where you have the 4 plus the 3, which is not greater than the 8. So the idea is there's no way we would be able to connect. First of all, 4 and 3 wouldn't even connect if we laid it on the third side. So as soon as we start pulling it away here and trying to create a triangle, there's no way for it to connect. So anytime you're looking at something to be an actual triangle, you're looking at examples. An equilateral is a good one, 5, 5, and 5, because no matter what combination of triangles you put together, it's always going to be greater than the third side. I always like throwing an odd number, like a 7 and a 12, and an even number. Now that's a good one to bring up, 7 and 12. Let's look at that. So let's say I were to ask if you had a triangle with sides 7 and 12, and what would be the range of your third side? What would be the range of x here? Now the idea is, you know that it needs to be greater than the third side. So if I do 7 plus 12, that's equal to 19. I know that this third side needs to be less than 19, because if it weren't, it would not be a triangle. And then I also need to figure out, well, what plus 7 equals 12? Well, I know 5 plus 7 equals 12. So this third side here can't be 5, because if I added it to the 7, would it be greater than the third side? So 5 plus 7 is greater than 12. So and if you're asked what is the biggest side, well, you would say it's 18, because that's the closest side, or that is the biggest the side could be without it no longer being greater than. And then smallest we would say 6 in this case. All right, because it fits within the range here. Now I like to take this triangle and also look at the perimeter, because that's a good question to ask. Basically, what is the range of your perimeter? You know you have sides 7 and 12. So if you're looking for the range of the perimeter, first find the range of the third side. First, find range of third side, and then use that to create your range for perimeter. So for instance, I have 19 and 5. So I know that my range of my perimeter is going to be somewhere in between 38 and 24. Because basically I'm doing 7 plus 12 plus the the smallest part of my range, and 7 plus 12 plus the biggest part of my range. And that's kind of what you have dealing with triangle inequality theorem, and just the idea of the two sides needing to be greater than the third.